What if I told you that many vehicle owners are unknowingly destroying their cars every time they clean their engines? According to automotive repair statistics, improper engine cleaning leads to billions in unnecessary repairs annually. After analyzing data from service centers and interviewing professional technicians, I've identified 6 critical engine components that should never be cleaned with any liquid or spray. One of these components costs less than $300 at the parts store, but will cost you over $2,100 when it fails after improper cleaning. And the most shocking part? The number one item on our list is precisely what most detailing videos tell you to clean first. Give this video a like if you want to protect your investment, and subscribe for weekly automotive information that can save you thousands in preventable repairs. Modern vehicles are packed with sensitive electronic components that can be easily damaged during routine maintenance. Understanding which components are most vulnerable can help you avoid costly repairs and extend the life of your vehicle. Let's get straight to the 6 engine parts you should never clean with any liquid, chemical, or pressure washer, no matter what those detailing videos tell you. Number 6. Oxygen sensors. We begin with one of the most critical yet vulnerable components of your engine management system, the oxygen sensors. These small, finger-sized devices monitor the precise ratio of air and fuel in your engine's exhaust, allowing the computer to make split-second adjustments for optimal performance and efficiency. Many drivers assume these sensors are safely protected within the exhaust system, far from any cleaning procedures. This is a dangerous assumption. According to Denso, one of the world's largest automotive sensor manufacturers, over 60% of oxygen sensor failures are caused by moisture contamination, not normal wear and tear. The electrical connectors and wiring for these sensors typically run through areas of the engine bay where cleaning sprays and water can easily penetrate. These connectors aren't completely sealed, and even indirect spray or mist can infiltrate them, beginning a silent process of corrosion that distorts the electrical signals sent to your vehicle's computer. The consequences affect both performance and your wallet. When oxygen sensors fail, your engine runs with incorrect fuel mixtures, dramatically increasing fuel consumption, potentially causing catalytic converter damage, and triggering the check engine light. Once damaged, these sensors cannot be cleaned or repaired. Complete replacement is the only solution, costing between $427 and $532 per sensor at typical repair shops, not including diagnostic fees and taxes. Most modern vehicles have between 2 and 4 of these sensors, potentially turning a simple engine cleaning into a $2,000 plus repair bill. To protect your oxygen sensors during any engine cleaning, identify their connectors and cover them completely with plastic bags secured with tape. Alternatively, apply a small amount of dielectric grease to the connections to repel moisture. This simple precaution can save you hundreds in unnecessary repairs. Number 5. Electronic throttle body. Moving to the second component on our list, the electronic throttle body. This critical device controls the amount of air entering your engine. In older vehicles with cable-operated throttles, cleaning this component was relatively safe. However, in modern vehicles with electronic throttle control, virtually all vehicles manufactured after 2005, this maintenance can lead to disaster. The electronic throttle body contains a precisely calibrated motor, micrometrically adjusted gears, and position sensors that constantly communicate with the engine control module. When aggressive cleaning products are introduced or the throttle plate is manually forced open, these sensitive components can become misaligned or the internal sensors damaged. The symptoms of a throttle body damaged by improper cleaning are unmistakable: unstable idle, erratic acceleration, sudden power loss, and even complete engine stalling at traffic lights. The most frustrating part is that once damaged, additional cleaning won't solve the problem. It often makes it worse. Major manufacturers, including General Motors, Toyota, and Volkswagen, have issued specific technical bulletins warning against manual cleaning of these components without proper calibration equipment. According to industry data, approximately 40% of throttle body replacements are directly linked to damage caused by DIY cleaning attempts. Replacement costs range from $555 to $756, depending on your vehicle model, with luxury or larger vehicles costing even more. If you absolutely must remove carbon buildup from this component, the correct approach is much more conservative. With the engine completely off, never with the key in the ignition position, gently apply a throttle body-specific cleaner to a microfiber cloth and carefully clean only the accessible edges without touching or forcing the valve itself. Never spray products directly or use tools to manually open the throttle plate. Number 4. Alternator. Our third component is responsible for generating all the electrical power that runs your vehicle systems and recharges the battery, the alternator. This component appears robust and sealed from the outside, but is extraordinarily vulnerable to moisture intrusion. Contrary to popular belief, alternators are not hermetically sealed. They require ventilation to cool their internal components during operation. This same characteristic makes them an easy target for moisture and chemicals during engine cleaning. Inside the alternator, you'll find delicate copper windings, rectifier diodes, bearings, and an electronic voltage regulator. When moisture penetrates these components, it initiates an oxidation process that may not manifest immediately, creating a false sense of security. Technical studies have shown that approximately 40% of premature alternator failures are directly linked to exposure to moisture or aggressive chemicals during engine cleaning procedures. The symptoms of an alternator damaged by moisture progress gradually and are often confused with battery problems, flickering or dimming lights, electronic systems that reset randomly, difficulty starting, and eventually complete battery discharge. Prevention is straightforward but critical. Before any engine cleaning, completely cover the alternator with a plastic bag sealed with tape. If you need to remove surface dust or dirt, use only a dry or slightly damp cloth without applying liquids directly. Remember that a new alternator typically costs between $555 and $756 before adding labor costs for installation. Some European or luxury vehicles can cost significantly more. This simple precaution can save you hundreds in unnecessary repairs and prevent being stranded with electrical system failures. Number 3. Ignition coils and spark plug wells. The fourth component on our list directly affects the heart of your engine's operation, the ignition coils, and the wells where spark plugs are housed. In virtually all modern fuel-injected engines, the coils are mounted directly on top of the spark plugs in the cylinder head in what's known as a coil-on-plug configuration. The elevated position of these components creates a dangerous illusion of safety. Many owners spray degreaser or water around these areas, thinking they're adequately protected. Nothing could be further from the truth. The spark plug wells are essentially cavities that can collect moisture. When water or degreaser seeps into these spaces, it creates a conductive path between the high voltage of the coil and the engine block ground. The result is a partial short circuit known as current leakage, which weakens the spark or diverts it completely. The symptoms are unmistakable: misfiring, especially on humid days, engine vibrations, power loss, and specific error codes like P0300 random misfires, or P0301P0306 cylinder-specific misfires. But the problem doesn't end there. If this moisture remains trapped in the spark plug wells, it initiates a corrosion process in the aluminum threads of the cylinder head and the electrical contacts of the coils. What began as a simple cleaning can transform into a costly repair requiring extraction of broken spark plugs or replacement of damaged coils. The correct way to maintain this area is minimalist. If you need to clean around the coils, use a slightly damp cloth without applying liquids directly. After any cleaning near this area, running the engine for at least 10 minutes will help evaporate any residual moisture. For additional protection, apply a small amount of dielectric grease to the coil connectors, a simple technique used by professional technicians. The cost of replacing damaged ignition coils can range from $60 to $150 per unit, not counting diagnostic time or potential collateral damage to the cylinder head threads. With 4, 6, or 8 coils in most engines, this can quickly become an expensive repair. Number 2. Mass airflow sensor. We've reached our fifth component, perhaps the most sensitive of all sensors in the modern engine, the mass airflow sensor, commonly known as the MAF sensor. This small device, typically located between the air filter box and the throttle body, is crucial for the precise operation of electronic fuel injection. Its job seems simple. Measure the exact amount of air entering the engine so that the control unit can calculate the precise amount of fuel needed. However, the technology behind this measurement is extraordinarily delicate. Inside, most MAF sensors contain heating elements made of platinum or similar precious metals with filaments finer than a human hair. These filaments are heated to a specific temperature, and the airflow cools them in direct proportion to its volume. This temperature difference is what the sensor translates into electrical signals that the control unit interprets. Here lies the critical problem. Any contact with liquids, even small particles of nebulized spray, can physically damage these microscopic filaments or leave residues that alter their thermal properties. Even compressed air used incorrectly can break these delicate elements. The symptoms of a damaged MAF sensor are wide-ranging and often confusing. Excessive fuel consumption, difficult starting, unstable idle, inconsistent acceleration, and eventually the activation of limp mode that drastically limits vehicle performance. According to data published by Bosch Automotive, one of the main manufacturers of these sensors, MAF contamination is among the top 3 causes of check engine light activation in vehicles less than 10 years old. The only safe way to treat this component is with extreme respect. Never spray any product near the air intake or filter box. If the sensor truly needs cleaning, something that should be determined by professional diagnosis, not by routine preventive maintenance, it should be carefully removed and treated exclusively with cleaners specifically designed for MAF sensors, allowing it to dry completely before reinstallation. Replacement costs for an MAF sensor can vary enormously depending on the vehicle, ranging from $240 to $684, including parts and labor. Some European or luxury vehicles can cost significantly more. This makes protecting this component during engine cleaning an absolute priority. Number 1. Catalytic converters and diesel particulate filters. And finally, we reach the component that should never be cleaned under any circumstances: emission treatment systems, specifically catalytic converters and diesel particulate filters, DPF-FAP. These components represent perhaps the point where good cleaning intentions can cause the most devastating financial damage. Located in the exhaust system, they're designed to reduce pollutant emissions through complex chemical reactions that occur at extremely high temperatures. The interior of these devices contains ceramic honeycomb structures coated with precious metals such as platinum, palladium, and rhodium, which act as catalysts to convert toxic gases into less harmful compounds. In the case of diesel particulate filters, they add a filtering matrix that physically captures soot particles. The catastrophic mistake many owners make is attempting to unclog these components when they detect power loss or increased consumption, either with water jets, chemical solvents, or even mechanical methods. These interventions have devastating consequences. Water introduced into these components instantly converts to steam when the system reaches its operating temperature, frequently exceeding 600 degrees Fahrenheit, generating violent expansions that fracture the interior ceramic structure. Chemicals, meanwhile, can dissolve or contaminate the precious metal coatings, rendering their catalytic capacity useless. Once damaged, these components cannot be recovered. The consequences are severe: permanent power loss, increased consumption, check engine light activation, and most critically, failure to meet emission standards that may result in the inability to pass mandatory technical inspections. The only legitimate maintenance for these systems is control regeneration in the case of DPFs, a procedure that must be performed using professional diagnostic equipment or through specific driving cycles recommended by the manufacturer. Any other direct intervention is counterproductive and potentially destructive. The cost of replacing a catalytic converter or a modern particulate filter is astronomical, ranging from $945 to $2,475 for just parts depending on the vehicle. For some high-end models, This figure can easily exceed $5,000. This makes protecting these components from cleaning damage an absolute financial priority. The truth about engine cleaning: after analyzing these 6 critical components, the fundamental question arises: should we forget completely about cleaning the engine? The answer is nuance. A moderately clean engine has legitimate advantages. It facilitates leak detection, slightly improves heat dissipation, and is certainly more aesthetically pleasing. However, this cleaning must be done with knowledge and extreme caution. The fundamental principles for safe cleaning are: 1. Always work with a completely cold engine and disconnected ignition, preferably also disconnecting the battery. 2. Meticulously protect all sensitive electrical and electronic components, including the alternator, distributor and older models, fuse box, connectors, and control units. 3. Completely avoid using pressure water systems. Instead, use slightly moistened cloths and specific products for engine cleaning applied with precision. 4. After any cleaning, ensure the engine is completely dry before attempting to start it, ideally waiting several hours. 5. If you don't have sufficient technical knowledge or experience, consider leaving this task to professionals who understand the specific risks for your vehicle model. Always remember this fundamental truth: engines are designed to function with a certain degree of external dirt. In fact, many components use this natural protective layer as part of their thermal and electrical insulation. An obsessively clean engine may look impressive in photographs, but it's potentially more exposed to electronic failures and corrosion than one with a normal pattern of use. If you've learned something new with this video, give it a like, share it, and subscribe for more technical content that protects your wallet and extends the life of your vehicle. In our next video, we'll analyze the 5 most costly mistakes owners make when washing the exterior of their cars, including one that is literally dissolving door seals in silence. Don't miss it.